Exercise 9F has us looking at exponential rates. Now we're looking at graphs of this sort of basic form, y equals e to the power of something. We might even have a constant out the front of the e, which means we're multiplying that by our exponential part. And in both of these examples, the k and the a would just be constants. Now, if we're talking about rates, rates are generally involving changes in a quantity over time. So instead of measuring some quantity with our y-axis and our x-axis, generally we measure this using t for time, and as time goes along, we're recording some kind of change in quantity that might be of an exponential nature. So there's a couple of things that happen with that. One is you've still got a y-axis, and here I've rewritten both of these equations, just replacing the x with a t. And you don't have to do anything special except just think of the t the way you would normally treat an x. And we have the t-axis here. So rewriting these, we need to become familiar with them because we often see t, where t is just time, and it'll tell you what the units are usually. It might be time 1, 2, 3 in seconds, or in minutes, or in hours, or days, whatever is specified in the question. Now the other thing that happens when you're using time is that if this is 0 on the time axis, often we'll only be measuring from 0 onwards. Although we can think about what might have happened before, most of this part of the graph in our course generally won't be used because time can't really be negative. We start at some starting point that's defined, and then we can look at what happens as time goes forwards. Now think about what your y-intercept will be, always by subbing in when t equals 0, and when you sub in t equals 0 here, you'll have e to the power of 0, y would be 1. If you have a constant out the front, then when you sub 0 in for t, no matter what k is, you'll have e to the power of 0, which is 1, and a times 1 will just be a. Okay, so you end up realising it's quite easy to find out what that intercept is. You can find any other points on the graph. And now that you know how to differentiate something like this, you should be able to find out more about the rate of change of what's happening as you move along than last time we didn't do exponentials.